Ashe. Dear friends, I am your royal narrator, Queen Magical Melanin, extending a warm greeting to all gathered for our basic applied electronics information session produced by our esteemed Baba Jelani Bomani Dembe, the brilliant mind behind Majestic Mind Matters University, and the mandatory Mental Liberation series, eagerly enriching our learning journey. Today, we venture into the world of basic applied electronics, where circuits and currents intertwine to unlock endless possibilities. Let us embark on this enlightening adventure together, exploring the wonders of technology and innovation under the guidance of our distinguished Baba Jelani Bomani Dembe. Welcome to a transformative experience that will ignite your curiosity and mastery in the field of applied electronics. So pay close attention and take plenty of notes to prepare you for possibly answering a few easy questions near the end of the session. In this basic applied electronic information session, you will be introduced to the current regulator. Current regulators are a vital component in the field of electronics, and applied electronics technicians must have a thorough understanding of how they work in order to effectively maintain and troubleshoot electronic devices. Current regulators are responsible for limiting the amount of current flowing through a circuit to a specific level, ensuring that the components within the circuit are not damaged by excessive current. In this essay, we will explore the basics of current regulators and what applied electronics technicians need to know about them. Current regulators are typically implemented using transistors, which are semiconductor devices that can control the flow of current in a circuit. There are two main types of current regulators: series regulators and shunt regulators. Series regulators are placed in series with the load, and they adjust the voltage across the load in order to maintain a constant current. Shunt regulators, on the other hand, are placed in parallel with the load, and they provide a path for excess current to bypass the load in order to maintain a constant current. Applied electronics technicians must understand how to calculate the value of the current limiting resistor in a series current regulator. The current limiting resistor is used to set the maximum current that can flow through the circuit. By determining the value of this resistor, technicians can ensure that the current regulator operates within the desired parameters and protects the components in the circuit from damage due to excessive current. Another important concept for applied electronics technicians to understand is the voltage drop across the current regulator. When current flows through a current regulator, there will be a voltage drop across the regulator due to the resistance of the components within the circuit. Technicians must be able to calculate the voltage drop in order to ensure that the current regulator is operating as intended and does not exceed the maximum voltage rating of the components in the circuit. In addition to understanding the basic principles of current regulators, applied electronics technicians must also be familiar with different types of current regulators and their applications. For example, linear regulators are commonly used in low-power applications where efficiency is not a major concern. These regulators use a linear voltage regulator to maintain a constant output voltage and current, but they can be less efficient than other types of regulators. Switching regulators, on the other hand, are more efficient and are commonly used in high-power applications where energy efficiency is a priority. These regulators use a switching mechanism to control the flow of current in the circuit, and they can provide a more stable output voltage and current while minimizing power loss. Applied electronics technicians must also be aware of the potential issues that can arise with current regulators, such as thermal runaway and stability problems. Thermal runaway can occur when the current regulator becomes too hot, causing the resistance of the components to decrease and allowing excessive current to flow through the circuit. Stability problems can occur when the current regulator oscillates or becomes unstable, leading to fluctuations in the output voltage and current. Current regulators are an essential component in the field of electronics, and applied electronics technicians must have a solid understanding of how they work in order to effectively maintain and troubleshoot electronic devices. By understanding the basic principles of current regulators, calculating the value of the current limiting resistor, and being familiar with different types of regulators and their applications, technicians can ensure that electronic devices operate efficiently and reliably. Regulators are essential components in electronic circuits that control the voltage or current levels to ensure proper functioning of electronic devices. However, They can sometimes malfunction due to various reasons such as loose connections, physical damage, overheating, or faulty components. Troubleshooting a regulator requires a systematic approach to identify and rectify the issue effectively. In this essay, we will explore 10 steps to troubleshoot a regulator and restore its functionality. The first step in troubleshooting a regulator is to check for loose connections. Loose connections can lead to fluctuations in the current output, affecting the performance of the regulator. It is essential to ensure that all connections are secure and properly tightened to prevent any issues related to poor connectivity. Next, testing the input and output voltage of the regulator using a multimeter is crucial. By comparing the measured values with the specified voltage range, any discrepancies can be identified, indicating a potential issue with the regulator's operation. This step helps in pinpointing the source of the problem and taking necessary corrective actions. Inspecting the regulator for physical damage is another important troubleshooting step. Visual examination for burnt components, broken wires, or bulging capacitors can help in identifying any visible signs of damage that may be causing the issue. Repair or replacement of damaged components is necessary to restore the regulator's functionality. Monitoring the temperature of the regulator during operation is crucial to check for overheating. Excessive heat can indicate a malfunctioning regulator or inadequate cooling, which can impact its performance. Proper ventilation and the presence of heat sinks are essential to prevent overheating issues in the regulator. Testing the components of the regulator, such as transistors, diodes, and capacitors, using a multimeter can help in identifying any faulty components that may be causing the problem. Replacement of faulty components is necessary to ensure proper operation of the regulator. Reviewing the circuit design of the regulator is essential to verify proper connections and component values. Any design flaws should be identified, and necessary adjustments should be made to correct them. This step ensures that the regulator operates as per its intended design. Consulting the manufacturer's data sheet or technical documentation for the regulator is crucial to understand its specifications and recommended troubleshooting procedures. This information can provide valuable insights into the regulator's operation and help in diagnosing and resolving issues effectively. Using a signal generator to apply a known input signal to the regulator can help in testing its response and output. By comparing the expected output with the actual output, any discrepancies can be identified, indicating potential issues with the regulator's performance. If all troubleshooting steps fail to resolve the issue, replacing the regulator with a new one may be necessary. It is important to use a compatible replacement and follow proper installation procedures to ensure the regulator functions correctly. Finally, seeking professional help from an electronics technician or engineer is recommended if the issue persists or if you are unsure about troubleshooting and repairing the regulator. Professionals can provide further guidance and expertise in solving the problem effectively. In conclusion, troubleshooting a regulator requires a systematic approach involving various steps such as checking for loose connections, testing voltage levels, inspecting for physical damage, monitoring overheating, testing components, reviewing circuit design, consulting technical documentation, using a signal generator, replacing the regulator if necessary, and seeking professional help when needed. By following these steps, one can effectively diagnose and resolve issues with regulators, ensuring proper functioning of electronic circuits and devices. Applied electronics technicians play a crucial role in ensuring the smooth operation of electronic devices and systems. They are responsible for troubleshooting and repairing various types of electronic equipment, including voltage regulators. Voltage regulators are essential components that help maintain a stable output voltage, preventing damage to sensitive electronics. To effectively diagnose and repair voltage regulators, technicians need to have a solid understanding of the following 10 key points. 1. Check for loose connections. One of the most common issues with voltage regulators is loose connections. Technicians should carefully inspect all connections to ensure they are secure and properly tightened. Loose connections can cause fluctuations in the current output, leading to unstable operation of the regulator. By checking for loose connections, technicians can quickly identify and resolve this common issue. 2. Test the input and output voltage. Using a multimeter, technicians should measure the input and output voltage of the regulator. By comparing the measured values with the specified voltage range, technicians can identify any discrepancies that may indicate a problem with the regulator. Testing the input and output voltage is a fundamental step in troubleshooting voltage regulators and should not be overlooked. 3. Inspect for physical damage. Another important aspect of troubleshooting voltage regulators is inspecting for physical damage. Technicians should visually inspect the regulator for any signs of damage, such as burnt components, broken wires, or bulging capacitors. Physical damage can impair the performance of the regulator and may require replacement of damaged components. By carefully inspecting for physical damage, technicians can determine the extent of the issue and take appropriate action. 4. Check for overheating. Overheating is a common problem with voltage regulators, especially when they are not adequately cooled. Technicians should monitor the temperature of the regulator during operation to detect any signs of overheating. Excessive heat can indicate a malfunctioning regulator or insufficient cooling, which can lead to performance issues. By ensuring proper ventilation and heatsink placement, technicians can prevent overheating and maintain the optimal operation of the regulator. 5. Test the components. In addition to checking for loose connections and physical damage, technicians should test the individual components of the regulator using a multimeter. Testing components such as transistors, diodes, and capacitors can help identify any faulty parts that may be causing the issue. By systematically testing the components, technicians can pinpoint the source of the problem and make targeted repairs as needed. 6. Review the circuit design. Understanding the circuit design of the regulator is crucial for troubleshooting and repairing it effectively. Technicians should verify the connections and component values in the circuit to ensure they are correct. Any design flaws or discrepancies should be addressed promptly to ensure the proper operation of the regulator. By reviewing the circuit design, technicians can identify potential issues and make necessary adjustments to resolve them. 7. Consult technical documentation. When troubleshooting voltage regulators, technicians should refer to the manufacturer's datasheet or technical documentation for guidance. The datasheet provides valuable information on the regulator's specifications, recommended troubleshooting procedures, and operating conditions. By consulting the technical documentation, technicians can gain a better understanding of the regulator and troubleshoot it accurately. 8. Use a signal generator. To test the response and output of the regulator, technicians can apply a known input signal using a signal generator. By comparing the expected output with the actual output, technicians can verify the performance of the regulator. This method helps identify any discrepancies or issues with the regulator's operation and enables technicians to make informed decisions about repairs. 9. Replace the regulator. If all troubleshooting steps fail to resolve the issue with the regulator, technicians may need to consider replacing it with a new one. It is essential to use a compatible replacement and follow proper installation procedures to ensure the regulator functions correctly. By replacing the regulator, technicians can restore the functionality of the electronic device and prevent further damage. 10. Seek professional help. In some cases, troubleshooting and repairing voltage regulators may require additional expertise and resources. If technicians are unable to resolve the issue on their own or are unsure about the troubleshooting process, they should seek assistance from a professional electronics technician or engineer. These experts can provide further guidance and support in diagnosing and repairing the regulator, ensuring the effective operation of the electronic device. In conclusion, applied electronics technicians play a critical role in diagnosing and repairing voltage regulators to ensure the reliability and performance of electronic devices. By following the key points outlined earlier, technicians can effectively troubleshoot voltage regulators and make informed decisions about repairs. By checking for loose connections, testing the input and output voltage, inspecting for physical damage, and following other essential steps, technicians can resolve issues with voltage regulators and maintain the optimal operation of electronic systems. By continuously improving their skills and knowledge, electronics technicians can enhance their ability to troubleshoot and repair voltage regulators effectively. Thanks for your participation in this special Majestic Mind Matters University Basic Applied Electronics Information session. Here is a special message to all applied electronic technicians. Your participation to Majestic Mind Matters University has been invaluable. Your expertise and commitment to excellence has elevated our research and knowledge in the field of applied electronics. Thank you for choosing Majestic Mind Matters University as a trusted source for our valuable applied electronics information. To aid to your success with this basic applied electronics information session titled Introduction to the Current Regulator. Stay woke. Ashe.